If you want to verify something and you started in grade 6 verifying, Ethan, your half. So in grade 6 when we started verifying, which was the very first time, you checked your answers. So you literally punched them in directly into the question that they gave you, right? And you saw if left side equals right side. That's all we did. We checked numerous times from grade 6 on. So you solved, you got an answer, you put it back in directly into the question that was typed, left side, right side, got an answer, right? That's all we're doing. So when we verify, you have to substitute the value in for all of the variables. So they give you a value to verify, you plug it in for every variable. Step 2, you determine the value of each of those trig ratios. Step 3, you're going to simplify, which is sometimes the hard part because it's algebra and your fraction skills are not always the greatest. We use fractions a lot. And then you're going to make sure that the left side equals the right side. If it's true, you put LS equals RS. Now this is the key thing. When verifying, never cross over the equal sign as it is an electric fence and you will be zapped and hurt. Quite badly, I might add. This is no joke. Zap. I wish your pen would just go flying away. I've said this before. So, if you cross over the equal sign, if you move something, if you try and prove, if you try and do any of that stuff, you are wrong. So, the moment you get the question, you plug in what they need you to plug in. You check down the left, you check down the right, till my 6-year-old could say, yes, that left side equals right side. That's what you have to keep going. Some people are like, oh, 1 over root 3 equals root 3 over 3. Well, those are the same. And then they go left side equals right side. My 6-year-old would say, no, that does not look the same. So my 6-year-old has to look at this and be like, yeah, it looks the same. If my 6-year-old goes, no, it doesn't, then you are not correct. You have to go one more step, rationalize the denominator, and then they would match. And then you could go LS equals RS. And my 6-year-old would say, yeah, those look the same. Not knowing what the heck they are, but knowing that they look the same. Okay? So, over here, you're going to need your formula sheet out. Not your formula sheet, sorry, you're going to need your unit circle out. Now, this is something to side note. I didn't do this before because I knew it could maybe overwhelm you. But we're going to do this anyways, for now. So if I gave you tan 30 is sine 30 divided by cos 30, correct? Sine 30 is a half. Sine 30 is a half divided by cos 30, which is root 3 over 2, which gets you a half times 2 over root 3, which gets you 1 over root 3 because the 2's cancel. Then you rationalize it, and it gets you root 3 over 3. So if you ever have a tan 30 reference angle, your answer is root 3 over 3. It just might be positive or negative depending on what quadrant you're in. Okay? If you want to do the math every single time and figure it out, go ahead. But tan 30 is root 3 over 3, and any tan 60 degree is just root 3. Now the cotans are opposite. If I give you cotan of 30, its answer is root 3. And if I give you cotan of 60, its answer is root 3 over 3. Now it could be positive or negative, because if I gave you like cotan 120, it would be over here, and cotan of 120, would equal negative root 3 over 3, because cotan is negative there, right? So you can actually take the sine and the cos and divide them every single time and just figure it out that way. Or you can say, hey, I know it's going to be one of these. And tan and cotan at 45s are always 1s or negative 1s, right? Because you're dividing root 2 over 2 divided by root 2 over 2. So this can help you save time. If you're like, no, thank you, I'm just going to show my steps all the time, please do. No problem, right? Totally fine. Okay. So this one says, verify that 60 degrees for secant is true, is what it should say. It doesn't really verify theta equals 60 for that. So the first step is to plug the 60 in. And please, don't run it right under here. All of you do. You'll like, wherever this is situated, no matter where I have it typed, you'll just like work down. There's no saying that has to happen. Right? So you'll work down here, and then you're like, oh crap, I ran out of room. And then you start working over here, and then a little bit over here. You don't have to do that. Where this is situated, you do not have to start. And you're laughing, but every single time I mark stuff, it's always like, boom, right down here. And then there's arrows, just random arrows everywhere, and it's chaotic and sad. So I'm going to start to the left, and I'm going to say secant 60 degrees equals tan of 60 degrees over sine of 60 degrees. Now I go right to my unit circle. I use all the information that I learned in chapter 4 to be able to do this. What's secant of 60? I go to 60, I go to cos, and then I flip it. What's secant of 60? 2. Because cos of 60 is a half, secant of 60 is 2. What's tan of 60? Tan of 60 is root 3, right? How could you do it? Well, you could go root 3 over 2 divided by a half, 2's cancel, and you get root 3. It's the same thing. Tan of 60 is root 3. What's sine of 60? Root 3 over 2. The moment I'm going to go stack even one of them as being a fraction, I stop myself and say, no, do not stack. What do I tell myself to do? Write it sideways. So I'm not going to go divided by root 3 over 2. I'm going to go divided by root 3 over 2. So I have to stop myself. Do not stack. All right. Now, this is something I have to drill into your heads for this and for proofs. The only time you can flip and kiss or flip and invert and multiply or whatever, this is the only time. Paying attention? Whole numerator is a fraction divided by whole denominator is a fraction. So my whole numerator is a fraction, my whole denominator is a fraction, I can flip, right? If my numerator was like this, do not write this, but say my numerator was like this, 1 divided by root 3 over 2 divided by, 1 plus root 3 over 2, say that's my numerator, divided by a half. Can I flip the half? People will flip it all the time. You actually can't. This has to be a full fraction numerator, full fraction denominator. So I put this all together first. Now it doesn't really rook you if your numerator isn't a full fraction, but it will rook you if your denominator isn't. This is why. Say I flip them. Say I have a half, my numerator is a half, divided by my denominator, which is 1 plus root 3 over 2. And if people won't put it in brackets, so they'll write it like this. What are they going to do? They're going to flip the 1. Or if you're like, do I flip that? If you're going, what do I flip? That's a chance for your brain to be like, don't. If you're like, do I flip it and that? Do I flip it? Just that or this? That. If you're doing that, be like, don't. It's not in a state that it can be flipped, right? This has to be turned into a whole fraction, 2 over 2. Make it a full fraction. Then flip. If you're questioning what can I flip, what should I flip, you should not flip. Stop yourself. Okay? So, and you're like, of course. No, it goes bad. People flip these all the time. So we have to stick into our heads as a reminder. We need to lock it in there. And we need to remember that I can only flip and multiply if on the left I have a full fraction and on the right I have a full fraction. Then I'm allowed to flip and multiply. Okay? If I don't have a full fraction on one of the other sides, I have to make it a full fraction before I can flip and multiply. If you can lock that in your head, your test mark will be lovely. If you can't, that goes wrong all the time, and you're never going to get a right answer. Okay? So I can flip this. So it's going to be 2 equals square root 3 over 1 times 2 over root 3. What can I do with those root 3's? You can cross them off because one's on the top and one's on the bottom. And so I get 2 equals 2. Now, would my 6-year-old say that's true? Yep. So then I can follow behind with LS equals RS. Enjoy the LS equals RS. It's the only short form you're allowed to do. Because LS equals RS actually is in a math textbook saying that that's left side, which is right side. So if my 6-year-old can say, yep, those match, then you can go LS equals RS. Okay? Verify this one. So x equals pi over 6. Our first step is to do what? Put in pi over 6, right? And start on the left side. So cotan of pi over 6 equals cos of pi over 6 divided by sine of pi over 6. If you're like, I don't like memorizing, totally fine. Go off to the side and do your cotan pi over 6. I always do them all off to the side so that I have them for myself. Cotan of pi over 6 is cos divided by sine at 30. So it's going to be root 3 over 2 divided by a half, which is root 3 over 2 times 2 over 1, which is root 3. So I write all my info off to the side so I'm prepared. So I know cotan pi over 6 is going to get replaced with root 3. What's cos of pi over 6 going to get replaced with? What's the x at pi over 6? Root 3 over 2. What's the sine of pi over 6? Going to equal a half. Now I have all my info to fill in. So cotan of pi over 6 is going to get replaced with root 3. That way I'm not having to do all the work throughout this horrific looking thing, right? I did it all off to the side. Cos of pi over 6 is root 3 over 2. My numerator is a fraction, so I'm immediately going to write these sideways. Because if my numerator or my denominator is a fraction, I'm not stacking them. Sine of pi over 6 is a half. Now, do I have a numerator and denominator that are full fractions? Yes, so I'm allowed to do what? Flip and multiply. So I get root 3 equals root 3 over 2 times 2 over 1. The 2's cancel, and I get root 3 equals root 3. My 6-year-old, knowing absolutely nothing about square roots, could she say that those pictures look the same? Yep. So then we can go LS equals RS. I have so many people write the second last step. They write this step here and then say LS equals RS. Yes, your brains may see that that's the same, but my 6-year-old wouldn't, and therefore they won't give you full marks because that side doesn't equal that side when I look at it. The last step I did root 3 equals root 3. That's legitimate, right? So you have to do that extra step to show that the left side actually equals the right side. Okay, we're going to flip over. You guys are going to try this one. We're doing 210. Remember, sine squared x just means sine 210 squared. The answer of sine 210 all squared. So this one's going to be 1 minus sine squared 210. Now I don't immediately go and fill in the 210, which some people do. Like they go and fill in what that actual answer is. You have to show the step where you're verifying that you're filling in 210. So this step where you actually write the 210 is very important. So please don't skip it. It's going to equal sine of 210, 210 degrees, cos of 210 degrees, cotan of 210 degrees. Now off to the side, if you need to show your work, you can. What's sine of 210? Sorry? Mm-hmm. And then cos of 210? And then cotan, if you want to show the work, cotan of 210 would be negative root 3 over 2. Well, that doesn't look like a negative. Divided by negative a half. So negative root 3 over 2 times negative 2 over 1, which is root 3. If you'd like to show it. If not, I think it warned. Oh, it's back. Okay. So we get 1 minus negative a half squared equals negative a half times negative root 3 over 2 times root 3 over 1. Now, some people are like, when do I cross multiply? When do I multiply straight across? You cross multiply across an equal sign. So cross multiply across an equal sign. Cross, cross, right? If there's no equal sign, it's just across the top, everything across the bottom. All numerators multiply, because you could literally do this. When these are all multiplied, I can just go like this. You can literally write them together, and the multiplications would be up here. That's all you do when it's multiplication of fractions. Numerator, 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 denominator, denominator, denominator. So I'm going to get 1 minus square of negative 1 is 1, square of 2 is 4, equals negative 1 times negative root 3 is root 3. Root 3 times root 3 is 3. 2 times 2 times 1 is 4. Now, I need to make a common denominator out of the 1. How can I do that? I can switch it to 4 over 4, because 4 divided by 4 is 1. I need a 4 for common denominator. When I have a common denominator, I can just write it and then do the operations at the top. 4 minus 1 is 3, and then 3/4, and then my 6-year-old says, yep, and then I go LS equals RS. Okay? This one we're going to do together. So we have 7 pi over 6. So remember the cos 2x, it's a double angle identity. It's because you're going to double the angle. That's why it's called the double angle identity. So we're going to go tan of 7 pi over 6 equals 1 minus cos 2 times 7 pi over 6. 2 is technically over a 1, if that makes you feel better. Over sine of 2 times 7 pi over 6. And once again, the 2 is over a 1. So we get tan of 7 pi over 6 equals 1 minus cos of 14 pi over 6, which I'm going to have to find its coterminal, over sine of 14 pi over 6. So I'm going to do tan of 7 pi over 6 first. Tan of 7 pi over 6 is negative a half divided by negative root 3 over 2, which equals negative a half times negative 2 over root 3, which equals 1 over root 3, which is root 3 over 3, but if you don't believe me, you can rationalize. You can show all this work if you really want to. Root 3 over 3. What the heck is 14 pi over 6 in degrees? (14 times 180 divided by 6. What do you get? Is it 420, I believe, or something like that? What's 14 times 180 divided by 6 in degrees? What you get? 420. Now I need to do what so I can find on my unit circle? Subtract 360, and I get 60. So these are just the answers at 60, right? So cos of 14 pi over 6 is a half, and sine of 14 pi over 6 is root 3 over 2. So I'm going to get root 3 over 3 equals 1 minus a half. Wait a second, I have a fraction. The moment I have a fraction, what am I going to do? Write them sideways. So people do this. Way more than the correct answer, they will do this. And then they'll take the root 3 over 2 and they'll flip it. What's my problem? I have 1 minus a half is my numerator, correct? So what I always do is if I have a full numerator over a full denominator, I force myself to put it into square brackets so that I remember that it's a full numerator over a full denominator. And I need to make that thing be the same. This has to be a full fraction, and it's not. How do I make it a full fraction? Yeah?
I just want to ask, do you have to use square brackets?
You can use round. You could use no brackets as long as you remember that it's that and that. But really using no brackets is actually not correct because you really need to have the whole top over the bottom. But you can use whatever bracket you want. So we have root 3 over 3. We can make common denominators, or we can go, what's 1 minus a half? A half. If we want to make common denominators, we can. We could write this as a 2 over 2, which still gets me a half. Divided by root 3 over 2. Now do I have my numerator divided by my denominator correctly? Full fractions? Yep. Root 3 over 3 equals a half times 2 over root 3. These cancel, and I get root 3 over 3 equals 1 over root 3. And people will say, well, when I type those in my calculator, they're actually correct, so I know I'm right. Left side equals right side. Once again, does my 6-year-old tell me that that's right? No, my 6-year-old will be like, those don't look anything alike, Mom. It's like, you're right, kid. You're right. So remember, my 6-year-old or your puppy has to be able to look at this and say that they're the same. So, root 3 over 3 equals root 3 over 3. All right, LS equals RS. And enjoy writing LS equals RS. It's your only short form you will ever get. Spell it, you know. Don't write right side equals left side. We do that a lot on the wrong sides.
Considered wrong.
I think we've given it as marks, but it's technically wrong if you write it on the wrong side. But it's a true statement. You just don't know your lefts and rights. Like, you can do all that. Just remember, whatever pencil you write with, if it's your right hand, that's your right hand. If it's your left hand, that's your left hand. So just pick up the one that you write with, and boom, you got your answer. Unless you're my 9-year-old, who I'm like, hey, well, just I can't ever remember. And I'm like, well, pick up your pencil. I'm like, that's not the pencil hand you ever picked up a pencil with in your entire life. How would you? She's like, I can't remember. I'm like, visualize, grab paper, right hand. She'll grab with her left. I'm like, oh my God. I'm like, I have no help for you. You will never know lefts and rights. That is with you. Okay. So, example 7, we have 120. Example 7, 7, 8, and then this is your homework. So example 7, we're going to go 1 minus cos of 120 degrees equals sine of 120 degrees equals sine of 120 degrees over 1 plus cos of 120 degrees. Help me out. Sine of 120 degrees is root 3 over 2. Cos of 120 degrees equals negative a half. So I'm going to get 1 minus negative a half. I have a fraction. I have a numerator. I am going to put that in brackets, and I'm going to write it sideways. Divided by sine of 120 is root 3 over 2. So you can put in square brackets and round brackets, doesn't matter. Then sine of 120 is root 3 over 2 divided by 1 plus negative a half. Now, am I able to flip any of those division symbols right now? Do I have full fraction divided by full fraction on either of them? Nope, so I can't flip them. So this one's going to be 1 plus a half, or if you need to, that's 3 over 2, but if you don't know that, go 2 divided by 2. Or your calculator can help you, and we wouldn't know you didn't know how to do addition of fractions. So you can get 3 over 2 divided by root 3 over 2 equals root 3 over 2 divided by 1 plus a negative a half is 1 minus a half, which is a half. Now do I have full fraction divided by full fraction? Yep. So can I flip now? Yep. So I get 3 over 2 times 2 over root 3 equals root 3 over 2 times 2 over 1. So I'm going to get 3 over root 3 equals root 3. And right now they don't look the same to me, so I'm going to rationalize. So I'm going to get 3 root 3 over 3 equals root 3. Root 3 equals root 3. Example 8 is going to be your hardest one. It has a radical you're going to have to rationalize by using conjugates, which you got taught in grade 11. So we'll see when we get there. So we have pi over 4 as our fill-in. So we're going to go 1 over 1 plus sine pi over 4. Equals secant pi over 4 minus sine pi over 4 secant pi over 4 over cos pi over 4. The great thing is pi over 4s are just root 2 over 2, right? Only when we have to figure out a secant. Secant pi over 4. Instead of root 2 over 2, it's going to be 2 over root 2, which when we rationalize, 2 root 2 over 2, which is just root 2. So for all the cos pi over 4s, we're going to get root 2 over 2s. And for the secants, we're going to get root 2. So I'm going to get 1 divided by bracket 1 plus root 2 over 2 equals root 2 minus root 2 over 2 times root 2. That's a complex numerator. Put it in brackets. Divided by root 2 over 2. Right now I'm not allowed to flip and multiply anything because neither of those are full fraction divided by full fraction. So I'm going to change this one to 2 over 2 so that I can put them together. So I'm going to get 1 divided by 2 plus root 2 all over 2. So that's one full fraction. Equals root 2 minus root 2 times root 2 is 2. Divided by 2 is 1. Divided by root 2 over 2. Now do I technically have full fractions over full fractions? This one's over 1. Yep. So I'll be able to flip them. So I'm going to get 1 times 2 over 2 plus root 2 equals root 2 minus 1 over 1 times 2 over root 2. 1 times anything is itself. So I'm going to get 2 over 2 plus root 2. I'll leave a space here. Equals, and then top times top, bottom times bottom. So I'm going to get 2 root 2 minus 2, and distribute it through, over root 2. So far this year, all we've done is rationalize denominators when they just have like a square root 3, or square root 2, or square root 5. And then we just multiply by that square root and it goes away, right? So the right-hand side's just that. I can multiply by root 2 and multiply by root 2. And on the right-hand side, I should distribute it through. So I'm going to get 2 times root 2 times root 2. And root 2 times root 2 is 2. So it's 2 times 2, which is 4. Minus 2 root 2 over 2. Yeah.
Why did the sign change from division to times?
Let's look at. Yeah.
Is this the thing where you just flip the sign and then multiply it?
Yeah. So when you have two terms, and one of them's a radical, and you need the radical to go away, it's called multiplying by the conjugate. Now I'm just going to quickly show you why. So if I have 2 plus root 3, and I need it to go away, I'm trying to get the radicals to go away, I multiply by 2 minus root 3, the complete opposite. The reason why is I get first times first, which is 4, and if I use opposite signs, my middle terms will go away. So I'm going to get minus 2 root 3 plus 2 root 3, and then root 3 times root 3 is 3, so I get minus 3. If I use conjugates, the radicals go away. So that's why you do that. That's why we're taught that in grade 11. So if I have 2 plus root 2, I need to multiply by 2 minus root 2, top and bottom. And the conjugate multiplying is going to come up in proofs as well. 2 times 2 is 4. 2 times negative root 2 is negative 2 root 2, which is starting to look good. The bottom, I'm just going to write it below here so as I'm writing the root. 2 times 2 is 4. Outside is minus 2 root 2. Inside is plus 2 root 2. Last is root 2 times root 2, so it's minus 2. 4 minus 2 is 2. Left side equals right side. If you're someone who's like, multiply by conjugate, what the heck is that, and why are you saying those words? Are they evil? I don't even know. Come in at lunch and ask. You might have just not really done a lot of work on it in distance learning, or you might have just copied off someone in their homework assignment. I don't know. Those are all options. Don't really care what you did. I need you to understand conjugates. So if you're like conjugate, schmonjugate, I have no idea. I've never heard that word before in my entire life. Please come in. I will help you. Okay? Because we're going to need to know conjugates. And I don't care if you don't know it. I care that you know it for the test. So if you don't know it now, no biggie. You need to know it for the test. So please come in and ask about conjugates if you don't know what a conjugate is. This is your homework. So your homework that needs to be submitted for this weekend is today's, and Thursdays. If you get it completed by Sunday, I do not care. If you take Saturday and Sunday to do it, if you can't do it tonight, these are kind of beefy. Fine, don't care. All right? I just want it by Monday. Okay? So it's just yesterday's and today's is for tonight. I have to type them into my thing.